Hello, my name is Julia Frank. I'm an associate professor at the Department of Ichthyology and Hydrobiology at the Biological Institute of Tomsk State University. My talk will be focused on microplastics, their sources, distribution and impacts in water ecosystems. Microplastics widespread in surface waters. There are some initiatives which are aimed at mapping data of microplastic and larger plastic litter concentrations in different parts of the world, like this map created and maintained by the project Litter Base from Alfred Wegener Institute in Germany. It's obviously to date that plastic pollution is ubiquitous, but quantitative estimates on the global abundance and weight of floating plastics are still limited. There is a global distribution map showing interactions between aquatic life and plastic litter. Litter Base currently comprises almost 2,000 scientific publications on interactions of organisms with litter. Ingestion was the most frequently observed interaction, followed by entanglement, which affects motility, often with fatal consequences. In addition, many species can settle on floating litter. If floating litter is carried over long distances by ocean or river currents, associated rafters can invade new areas. Until now, interactions were reported for more than 3.8 thousand species of microorganisms, plants and animals. Plastics consist of different polymers that can be buoyant, neutral or sink depending upon composition, density and shape of the plastic. Polypropylene and polyethylene are typically low-density plastics that are expected to be relatively buoyant, while polyvinyl chloride, polystyrol, polyester and polyamide are considered high-density plastics that are more likely to sink. However, polyethylene and polypropylene can become high-density polymers as a result of addition of mineral fillers during production. Density of the parent material alone doesn't dictate the location of the particle within the aquatic environment. Turbulence and storm activity can cause resuspension of high-density microplastics and redistribution throughout the water column. Biofouling can occur, as can absorption of clay minerals, increasing the density and weight of the microplastic particle and resulting in sinking. Depending on its density, plastic first accumulates in the water column of central convergence zones and floats at the surface or sink to the floor after loading with biotic and abiotic dissolved compounds. Plastics can contain a wide variety of additives. They can include plasticizers, pigments, UV and heat stabilizers, antistatic agents, and others. Bisphenol and phthalates are probably most known of them. Bisphenol A, or BPA, a chemical regularly used to harden clear plastic bottles and food containers. It can migrate from these objects into the environment. BPA can act like estrogen in the body and affect endocrine system, potentially change the timing of puberty, decrease fertility, increase body fat, and affect the nervous and immune systems. BPA is now banned in baby cups and sippy cups. Canada was the first country to do so in 2008. The flexible plastic and vinyl tubes used in industrial food production contain phthalates in order to make the product flexible yet harder to break. This chemical may affect endocrine system in warm-blooded and contribute to cardiovascular disease. In 2017, the use of phthalates in child care products, such as teething rings, was banned. The exchange of additives or contaminants between microplastic particles and the surrounding water depends on the concentration gradient, the matrix in which the microplastics are present, physical and chemical properties of the plastic polymer and chemical and degradation processes acting upon the microplastic particles. In addition to the compounds used in plastic manufacturing, there is also potential for exposure of aquatic biota to other contaminants that absorb to microplastic particles. Microplastics are typically hydrophobic and have large surface areas, allowing them to accumulate organic pollutants such as polycyclic aromatic hydrocarbons, polybrominated diphenyl ethers, polychlorinated biphenyls, DDT, and others. These substances have been shown to absorb onto microplastics at concentrations that are several orders of magnitude higher than in the surrounding water, increasing the exposure of aquatic organisms. Likewise, plastic particles can associate with metals. Several recent studies demonstrate the ability of microplastics to accumulate metals to greater concentrations than in the surrounding water, potentially increasing exposure concentrations for aquatic organisms ingesting these particles. So, in the environment, microplastics can absorb other environmental pollutants, facilitating their transport in trophic chains, manifesting the so-called Trojan horse effect. There are numerous ways through which microplastics and associated contaminants can be incorporated by the aquatic biota. This includes filter feeding, suspension feeding, inhalation at air-water surface, and consumption of prey exposed to microplastics or via direct ingestion. Microplastics can be assimilated into the food chain at different trophic levels. Because of its particularly small size, microplastics are easily ingested by plankton and filter-feeding animals, which are not capable of properly selecting their food. It has been proven by many studies that microplastics are entering our food web, and as top predators, human beings are exposed to its potential harms. Much of the recent research of the assessment of microplastic accumulation in fish has focused on detection of particles in the gastrointestinal tract, but it's known that smaller particles can be concentrated in other organs and tissues eaten. Previously, small plastic fragments were believed to pass through the gastrointestinal tract without exerting a biological effect upon entering the body of animals and humans. However, studies have shown that micro and submicroplastics are potentially hazardous to human health. It's known that nano-sized particles from the gastrointestinal tract can enter the bloodstream and lymphatic system and accumulate in animal tissues. Accumulated data indicate that in living organisms, microplastics can trigger a whole range of negative physiological effects: nutritional problems, disturbances in energy metabolism, immune and endocrine system functioning, changes in liver function, neurotoxicity, reduced reproductive function, and so on. Thank you for your attention and see you next time.